Hello class, we're going to start today talking about volumes of prisms and cylinders. And just as a reminder, when we talk about a prism or a cylinder, what we mean is to have a shape or a solid, a three-dimensional shape, that has the same two shapes on bottom, we call those the bases, with parallel lateral sides. You could have a different base on top and bottom. Let's say you had a base that had a triangle, and then you have your lateral faces. And then in a cylinder, the only difference there is you have a circle on top and bottom. Okay? Now, volume would mean to fill these up. If you can imagine, like, if you were filling this box or this cylinder with liquid, and it's all the inside of our shape, similar to area, but volume, it's area in 3 dimensions. So, you can fill up any of these. And the formula that you get when you are finding volume is V equals big B times big H. And I want to specify what those two mean. Big B, the reason I don't use lowercase b is because I want this to represent the area of the entire base. Whereas if you were talking about B as in just base, that would be a two-dimensional figure and it would probably be along the bottom. For the same reason, I'm using capital H to be height of the solid, because similarly to base of a two-dimensional shape, you can also have the height of a two-dimensional shape. So just remember, with every degree, we're going to make our cases bigger so that we can differentiate different heights of the shape in 2 dimensions and in 3 dimensions. So for instance, if I were to find the volume of each of these figures, the volume would first be this for all of them. But then you have to think about, okay, well, how do I find the area of the base? Because all the bases are different. So like our first one's a square base. So you might say this is side times side times h, which would be going vertically. So there's your two sides. If you talked about the area of a triangle, that's 1/2 base times height. So you'd have to come down here, you'd have to say, okay, this is my base. Maybe you have to use the Pythagorean theorem to find your height. But the height of the entire shape, that would be big H. And the last one here, area of a circle, that's pi r squared, and that would be timesing by h. So big B is going to assume a different first half of your formula depending on the solid that you're looking at. So take our first example here. If we wanted to find the area of the base, okay, so we want the volume of the whole thing, but piece by piece, we start with an area problem. And let me explain why this formula just makes sense if you really think about it. I'm going to color in the area of a 14 by 14, so it's side times side, and then don't forget your h. 14 times 14, and then what do you think h is? You got it. So what we're doing here is we're saying, okay, I'm going to stratify this in levels. There's an area, like tiles. There's an area, there's an area, there's an area. And area doesn't have height, so there's an infinite amount of these. And if I shade in the whole thing, I have the volume. So what you're basically starting off is you're saying, okay, I want to find how much space that's taking up, and then raising it through space until you stop at a certain point where you say, okay, that's my 3-dimensional shape. Final answer is 2156. Let's say units cubed. 3 dimensions is always going to be cubed. That's something new. Okay, cubic units. Let's say you're talking about a cylinder. The formula is the same until you start kind of substituting things in. So like the area of your base, since your base is a circle, that's going to be pi r squared. And then h is going to be the height. So that's pi times 8 squared, go ahead and label r, times 10. Alright, now there's 2 ways you can do this. The first way is going to be in terms of pi. meaning we're going to leave pi in our answer, and we're just going to concern ourselves with those three numbers. So when I say three numbers, I mean 8 to the second, which is 64, times 10. And this can technically be your answer if you want your answer in terms of pi. Don't think that your volume is 640. It's actually much larger than that. Remember that 640 is just the first coefficient. It's also got a pi on there. So if you substitute, let's say pi is 3.14. A lot of times I would just look for the pi button. It'll be more accurate. But if I multiply that, that's going to give me some decimal. And you can see the actual volume. So these are equivalent answers. The actual volume is a much larger number when your answer is not in terms of pi. When it's in terms of pi, always remember it's kind of like you're leaving out that last multiplication step. Okay, either answer will work. I think Pearson, though, likes this one. Okay, go ahead and try to finish up on your Pearsons that you had last week. You can do any assignment late, and you have a volume assignment for today due tomorrow.